welcome to this YouTube channel Easy Engineering. Hope you all are doing good. And in today's class, we are going to resume the uh, previous two classes, which are Cognizant Cluster 1 and Cluster 2. So, this is all about Cluster 3. In Cluster 3, we are having C Sharp programming language, and we are having SQL and having Web UI. Okay, yes. So, in today's class, it is all about coding. So, that's why I'm just focusing on coding. So, I am going to explain you some of the questions about C sharp programming language in cluster 3. Okay, so let's get into the video. And when comes to the first question, it is check prime number. That means you need to check whether a given number is prime or not. So, here comes the example. When the input is given as 11, as 11 is a prime, the output should be prime. And when the input is given as 12, then as 12 is not a prime, so the output need to be not prime. How we will be doing this? What is the logic behind this problem? So first we are using system, because to access all the library methods, so we are using system. That means in system we'll be having all the library functions. And next we are creating a class with the name prime check. This is a variable name, and inside we are starting with static void main, which is the starting point or entry point of the program. And inside this we are creating creating a variable n, which is of integer data type, and assigning the value as the user input. Yes, in example 1, the user input is 11. So here we are using 11. Okay. Yes, after that, see, we are creating a boolean variable with is true, is prime, as assigned it to true. And if n is less than 2, means if that number is less than 2, then it won't be prime. Okay. So we have done that also, because if n is less than 2, then it will be definitely not prime, because 1 is not prime and nor a composite number. So is prime is false. Here we are only considering prime and not prime. Okay. Yes. And next we are taking a for loop, and inside that we are assigning the value of I to 2, because the prime or composite starts from 2. And next I is less than or equals to square root of n. That means, see, if you just verify up to square root of n, means root of n root of n, then you will be definitely knowing whether it is a prime number or not. There is no need to check um all the numbers from 1 to n. If n is a largest number, then there is no chance to check all of them. So square root will be checked to get whether that is a prime number or not. So here we are just say taking I is less than or equals to math dot square root of n. That means taking the root value of n. Okay. And finally we are incrementing the value of I, because a value of I is 2, right? So we need to increment it line by line. Okay, means iteration by iteration. And inside this for loop we are having if statement. In if statement we are having n percentile I, that means n modulo I equals to 0, then I prime is false. That means if n is what if n is divided by I, then it is not a prime number, because if it is divisible by another number rather than n or 1, then it is not a prime number. So is prime is false, and then you need to break the condition and you need to go out of the loop, right? Yes. So finally you will be going to print that is prime is what, prime or not prime. Okay. So like that, if it is not true, then you will be going out of the loop and you will be again coming to this for loop and you will be checking it again, like that. So I hope you have understood this first program, which is check prime number. And when going to the next one is Armstrong number. Question number 2, right? Armstrong number. The question is Armstrong number, and see what is a Armstrong number. A number is Armstrong if sum of digits power number of digits equals to number itself. That means this is not a correct one. So you need to, what is the Armstrong number means? When you cube the individual digits of a number and add them all, then you will be getting the same number. That is known as Armstrong number. So how we will be solving this question? So using system, we are again using system because we need some what we need some library methods. So for that purpose we are using system. Okay. And we have created the class Armstrong check, and inside the this class we are starting with static void main and creating a variable num and assigning it to the user input 153. And next we are creating again a sum variable and assigning it to 0. And we are creating a temporary variable and means duplicating the value of number num to temp. Okay. And after that creating another variable called digits and num dot to string dot length. That means this number will be um converted into string, and then the length will be find it, means total number of digits will be find it, right? And next we are having the while loop, and inside this while loop we are checking whether the temp is greater than 0 or not. Temp is nothing but none, that means 153. Whether 153 is greater than or not, greater than 0 or not is checked. Yes, 153 is definitely greater than 0. And next we are having int d equals to 10% n. That means uh, we are creating a variable d and taking the individual numbers. See, when you do modulo with 10, then you will be getting the last digit, which is 3, right? So d will be assigned to 3. D will be assigned to 3. Next we are having sum. Sum is 0 initially. We have already declared it. But now see, math dot power d comma digits. That means d power digits is done and it is converted into integer and it is added to sum. Okay. Yes, like that, and that temp is again divided by 10 and is assigned to the temp itself. Okay. Now again this while loop will be run, and again we'll be getting the last digit, and again we'll be doing the power and add it to sum, and we are again dividing by 10. So like this all the iterations will be done. And for the for the last one, see, we are going to check whether that number is equals to the sum or not. If both are equal, then print yes. If not, printing no. Second question is also completed in Armstrong number. This is third question. So third question is all about Fibonacci series. Uh, I think you know what is Fibonacci series. Or if not, I'll be explaining you very clearly now in fast forward mode. So Fibonacci series with n terms. Okay. So the n value will be given as input and the output need to be see six numbers. How this will be done? See, the first and second will be 0 comma 0 and 1 itself. Those are constant, we cannot do anything with them. And next we are having this one. How we will be getting this one? So we need to add both the previous numbers, 0 plus 1. If you add 0 plus 1, then you will be getting 1, right? And how we will be getting 2? You need to add previous two numbers, 1 and 1. When you add 1 and 1, then you will be getting 2. And when you add 2 and 3, 2 and 1, then you will be getting 3. Then when you add 3 and 2, then you will be getting 5. And if you want to get this next number, we need to add 5 and 3. Then you will be getting the next number, which is 8. Right? I hope you understood now what is Fibonacci series. So for this, what is the logic? Using system, and we are creating a class which is named Fibonacci series, and we have started with static void main, and inside this we have given the integer value n. We have created an integer variable n and assigned it the value taken from the user. Okay. Yes. And next, as I have said, the first two will be same. So we are creating a and b variables and assigning it to 0 and 1. Okay. Yes. Now we have took a for loop so that we'll be getting the rest of the numbers. Okay. In for loop, we are just initializing I to 0, and we are checking whether that I is less than 1, less than n, because all the numbers should be 6 itself. 6 numbers we need. So we are incrementing the value one by one. Okay. Yes. And after this, we are having inside this we are printing the value of a, and next we are adding the value of a and b. I hope you understood. And a will be equals to b now, and b will be equals to next now. And when you clearly understood this one, then you will be definitely understanding this one, because see, the next one will be the addition of previous two numbers, right, which are 0 and 1. And now a and b values should be changed. So b will be becoming a now, and this b will be, oh, a will be becoming b now, and this b will be becoming next. So that we have done here, a equals to b and b equals to next. That's it. All this for loop will be uh, run throughout the condition is false. Okay. This is all about Fibonacci series of n terms. And next we are going to discuss about fourth question. Yes, the fourth question is factorial using recursion. That means when the input is 5, then the output need to be 120. I think all of you known about factorial. What is a factorial? let's see with 1 5 factorial. This is 1 into 2 into 3 into 4 into 5. This is factorial. When you do all these digits multiplication, then you will be getting the final answer as 120. Right? This is a factorial, means multiplying numbers from 1 to n. That means what you need to remember is, when you need to find n factorial, then you need to go 1 into 2 into 3 into 4, so on, into n minus 1 into n, right? This will give you the answer of factorial. Okay, yes, that is known as factorial. And let's go to the logic, how we are going to solve it. Okay, and using system. Next, we are creating a class named factorial using recursion. I have used a short form here, and inside the class we have created a function named factorial, because recursion is nothing but calling function itself. So for that we need a function. So static int function int factorial. Factorial is the name of the function, which is a variable, and inside we are having the parameters as n. And inside this function we are having, if n equals to 0, return 1. That means if n is 0, when you are given a number 0 to find factorial, then the factorial will be 1 itself. Okay, and next, we are directly returning, if n is not equals to 0, then we are directly returning n into factorial of n minus 1. Okay, that means, see here we are having factorial of n minus 1, that will again go to here, and again go to here, and will again run this loop. This is known as recursion. Okay, and let's see the starting of the program. From main, the program will be started. So num is 5 here, and we are directly printing factorial of num. So this factorial of num will be taking you to here, and all this process will be done. Okay, and when you see this, um, easily we can write like this. See, n into n minus 1 factorial, right? N into n minus 1 means, see, this n is like this only, and when you see from this 1 to n minus 1, this is n minus 1 factorial. That's why I have written n minus 1 factorial here. So by this one, by this logic, we are doing, by this itself we are doing the recursion part. Okay, and I hope you have understood this question too. And the next question is, this is a final question and we have completed. And the fifth question is, sum of digits until single digit, digital routing. That means, see, we are having 9875, and when you add all the digits, you are getting 29. And when you add all the digits, we are getting 11. And when you add all the digits, we are getting 2. Then until you get a single digit, you need to add all the digits consecutively. Okay, here we have got 2, so we have stopped it. Okay, so the output will be 2. And how we will be doing this, using system, and we are creating a class digital root, and inside we are again creating a function called find root, and inside this one we are having a parameter n is a input number. So while n is greater than or equals to 10, that means while this n is greater than or equals to 10, because uh, when n is less than 0 it is single digit, right? So directly n will be equals to sum. Okay, so we'll be directly, okay, not this, uh, directly we will be returning n because it is already single digit. There is no need to do to single digit. Okay, so if it is greater than or equals to 10, then we are creating a variable sum and assigning it with 0, and we are having while n is greater than 0, then you need to add modulo of 10, means we are adding digit by digit, all the digits and divided by 10 again, and again add all the digits, divide by 10, add digits, divide by 10, like that. So finally you will be getting the sum, value of sum, then that is assigned to n, then we will be returning, see, then again it will be go to the while loop, then if it is again greater than or equals to 10, this process will be continued again. If not, then we'll directly return n. Okay, this program is also completed. I have very less programs for cluster 3 because I'm not so much perfect in cluster 3, so I have done these questions. Okay, that's all for today's class. And if you watched this video till now, then do subscribe to this video and do subscribe to this channel and do like this video. And if you like this video, keep supporting me, and in the description box I have given you the Telegram group link. If you are interested, then you can join. There will be giving all the jobs updates, and apply links will be provided there. Okay, that's all for today's video. Let's meet in the next class. Thank you.